My name is Nigel Kaiser, and this is my presentation on giant honeybee waves and the superorganism defense. So in honeybees, we see the development of what can be called a superorganism, i.e. the hive. The main idea being that in some ways it makes more sense to treat the hive as being a living entity. So for honeybees, the independent survival and reproduction of individual bees is far less important than the survival and reproduction of the hive. In addition, we see individual bees specializing to fulfill certain roles that's analogous to roles of cells for regular organisms. So, viewing the hive in this manner, we see the bees as performing a similar role as cells. And while there are a lot of different ways we can take this and make it more rigorous, the main point I want to focus on is this idea of locality. So individual bees, just like cells, have no sense or major control over the larger being they are a part of. Instead, they react to stimuli either from the environment or from other individuals, and in turn produce their own stimuli to promote or obstruct certain behaviors. And I want to point out this is true not only for the worker bees and things like muscle cells, but also for individuals we see as being more central to the main organism, like brain cells or the queen bee. While this may seem obvious on some level, it's from these local interaction that we see the creation of larger dynamics. Right, so for example, brain cells might be able to send and receive electrical pulses, but somehow enough of these local interaction of brain cells can lead to more complicated structure that would allow me to make a presentation. Or similarly, a bee releasing alarm pheromone might be simple by itself, but that leads to larger scale dynamics to defend the hive. And it's from here that I want to transition into what I think is a really cool example, which is this wave or shimmering behavior seen on the hive of giant agent honeybees. So in this video, all these bees are on the outside of their nests on the comb, and they're flicking up their abdomens in a similar manner that you kind of see people doing the wave at sporting events. And they only do this when they sense a wasp is near, as a way to deter the wasps from coming in closer. So the process actually has nothing to do with the cool visual you just saw, but instead the release and fanning of Nathan-off pheromone. This pheromone both let the wasp know they should not get any closer, and also probably needs to get away, and also tell the other guard bees on the comb that there is a danger nearby, and they should follow suit and also start fanning more Nathan-off pheromone to scare away the threat. So here's a nice visual seeing how the wave propagates. The white circle here represents a wasp moving to the left each frame of a video, with the red dots denoting guard bees sticking up their abdomen, as a whole giving us a water-like ripple sort of pattern. So the cool part is, though, that not all these guard bees are alike. So on the comb, there are what are referred to in the literature as special agent bees. And these bees are somehow better able to sense incoming wasps and are better at initiating the wave. So this image sort of gives proof of these special agent bees. The red dots show the strength of response initially to a wasp flying by in a given area, while the blue squares denote a response after the wasp has left. And so what we see is, about 5 or so of these centimeters squared do most of the initial warning to the rest of the guard bees on the surface. Right, and so these special agent bees really get back to the idea of specialized individuals interacting at a local level, creating a more complicated dynamic to defend the larger organism, much in the same way that our immune system defends our body from outside invaders. And that's all I got. I would highly recommend going out and looking up these giant Asian honeybee shimmering videos. They're pretty fun to watch. Thanks. And here are all the references I use in my paper. And also, I do want to give a big shout out to this guy named Gerald Kasperger. Um, who's done most of the research on these giant Asian honeybees and their shimmering behavior.